Hi, welcome to another episode of I Can Alteryx That with coaches Alex and John. I'm John. Today we're going to cover Alteryx Weekly Challenge number 213, Optimized Flower Arrangements. Let's get started. Alright, so in this challenge, we've been given a data set of flowers and their prices. We have 7 flowers and then 1 filler green. And our goal is to create 10 different floral arrangements using these flowers and greens. For each arrangement, we have to use between 4 and 8 of these 7 flowers, and then between 3 and 4 filler greens. So, because we need to make 10 arrangements, that tells us that we need between 40 and 80 each of these 7 flowers, and between 30 and 40 filler greens. And this is subject to the constraint that the total price must be under $950. So you can see if we look at the output, this gives us the objective value is the amount of money spent. Or pardon me, the number of flowers purchased. It doesn't tell us the amount of money spent. And then the number of flowers used for each of the different types. So you can see we maximized red and white carnations, 57 red roses, and we used the lower bound on the rest of the flowers and the upper bound on filler greens. So to do this, go to the prescriptive tool palette and grab an optimization tool. So since most people have probably never used this tool, it has 4 different inputs. O, which is our model inputs that contains our upper and lower bounds, if a thing should be included or not, the type, things like that. A will be the values, so the prices in this case. And then B will be the actual constraint, so our budget of $950. So before we can connect to that, what we have to do is actually identify what those boundaries are. So we use a formula tool to do that. So let's identify the lower bound. Just say if the flower equals filler greens, then the lower bound is 30. Otherwise, it's 40. I'll call that integer. We'll make a new field, call this UB. And then now we're going to change the 30 to a 40 and the 40 to an 80 for the upper bounds. Again, make sure it's an integer. We'll have an include column, and that's just going to be 1, because every flower has to be included in every arrangement. This basically forces each flower to be included, and we'll call that an integer. And then finally, we'll have a type column. So there's 3 different types. I believe there's 3 different types. And in our case, we want I, which stands for integer, meaning that all of the outputs must be integer outputs. There is a continuous, I want to say, and if we run this with continuous outputs, for example, instead of 417, we might get like 417.11111 or something ridiculous like that. I think there's also a binary type, which is B. But in any case, those are the ones that we need. Or that's the one that we need right here. So we need to split this data set right here. Because in the optimization tool, when you have specify the model as matrices, you must have an input connected to O, and you must have an input connected to A. So what we're going to do is grab a select tool, and for our O input, all I'm going to do is deselect price. Connect that to O. For the A input, I'm going to do the reverse of that. I'm going to deselect everything other than price. And we don't have our constraint input, so I'm going to go ahead and grab a text input tool, and I'm going to make that from scratch right here. So I'm going to call this constraint. Direction and right hand side. These are, as far as I can tell, these are like the conventional names. So our constraint is the price field must be less than or equal to 950. And we'll connect that to the B input. So we've got our specify model as matrices. That's good. This is a linear programming model. We'll just leave the solver alone. We're maximizing the objective, so turn that on. So for our input anchor A, we've got 3 options. Dense matrix, constraints in rows, or variables in rows, and then our slam matrix. In our case, if we look back here, it's going to go ahead and whatever. So you can see in our original data set, our variables, the flower names, are in the rows. So right here, we need to make sure we change this to dense matrix variables in rows. And finally, we're going to field map anchor O. Because we're not using the conventional names, we want to pick our field mappings manually. So our variables is the flower. The coefficient is include. Lower bound is LB, upper bound is UB, and our type is type. There's 3 different outputs here, but to match the output that we care about, that's the S output. So if we go ahead and run this, if we did everything correctly, we should match the output that we need to for this challenge. And we can see right here, it's a perfect match. So we used, again, our maximum number of red and white carnations, our minimum number of white daisy, white calla lilies, red daisies, spider mums, the maximum amount of filler greens, and then an intermediate amount, 57, of red roses. And of course, you could do the math and figure out what this price came to. I'm assuming it's pretty close to $950. You know, within a few cents of that, I'd imagine. But in any case, that is how you solve Alteryx Weekly Challenge number 213. Thanks for watching. As always, thanks for watching the video. Don't forget to subscribe to the Data Coach channel for more awesome lessons on Alteryx and all things data analytics and visualization. Follow Data Coach on Twitter at AskTessellation and follow me personally at jemery_dataviz. Thanks again.